Section 7.1 is Introduction to Linear Regression. In this section, the underlying setting that we'll always have is that we have one population, and that population is going to be described by two variables that are both quantitative. So let's get an example. So one population that we might want to study, if we were studying the trees in an old growth forest, that can be our population. So our population is all trees of a certain species in an old growth forest. And there's a lot of variables that we could associate with the tree, but two that we might be interested in studying are their diameter and their age. And so these are both quantitative variables. They're numerical variables where the numbers have numerical meaning. And when we have this sort of situation, when we have a single population and multiple variables, there are two main things we might want to do with these variables. One thing we could do, which is we'll leave until section 7.2, is we could just simply ask, is there a relationship between these variables? That is to say, if I know something about the value of one of the variables, does that tell me anything about the value of the other? The second thing we might try to do, which is what we're going to do in this section, is try to make predictions. Now, it doesn't really make sense to make predictions unless the variables are truly related, but the idea here would be, I wrote ages here, it should be age. The idea here would be that maybe we could predict the value of one of these variables based on the other. We could predict a tree's diameter based on its age, or we could predict a tree's age based on its diameter. And both of those predictions in various situations would make sense. That is, it would be reasonable to predict the diameter of a tree based on its age, if you just wanted to have a sense in general for how wide trees are at a certain age. But it also might make sense to predict the other direction, because if you think about trees, the way I know of that you figure out how old a tree is you cut it down and you count the number of rings. And I know there's more or maybe less destructive ways of doing this. I think there are ways of figuring out a tree's age without cutting it down, but certainly measuring the diameter of a tree is a lot easier to do than any of these methods where you'd calculate its age. So it might also be reasonable to predict a tree's age based on its diameter, so that you could go and measure the diameter of a tree and then have a guess for how old it was. And so that's what we're going to do in section 7.1. And so when we have this sort of situation, we have two variables and we're trying to predict one based on the other. The first thing we might want to do is we might want to graph these. So let's say what we did in this situation where we're studying all of the trees in the forest, but we have a sample of just some of the trees. And for these 100 trees, we'll actually go and figure out what their diameter and age is. So we measure the diameter and I guess calculate their age using some method, whatever method we have to calculate the age of a tree without cutting it down. So we do this and we want to see if these are related. So one of the first most natural things to do would be to plot these two variables on a graph. And so this is what's known as a scatter plot. So right here is a scatter plot. And so here we have on the x-axis the age of a tree measured in years. So I guess this is maybe not too old of trees. And on the y-axis we have, or sorry, no, this makes sense. I'm confusing myself. The x-axis is the diameter of the tree, right? That's the thing we're trying to make the prediction from. So the diameter of these trees in inches is given on the x-axis, and the y-axis is the age of the tree. So these trees are actually pretty old, right? They're ranging from a little under 60 years to almost 200 years. So here we have this scatter plot, and each dot in the scatter plot represents one of the trees in our sample. So any dot in this represents a tree. Its x value, the value on the horizontal axis, is its diameter in inches, and its y value, the value on the vertical axis, is its age in years. And looking at this graph, it does look like there's a relationship between these two variables and that we can make predictions. And in particular, it looks like there's maybe a linear relationship, which is what we'll deal with in this section. We'll only talk about in Module 7, linear relationships between quantitative variables. Given that it appears to be approximately linear, it's natural to draw in a line that goes kind of through the middle of everything. And when we talk about predicting, in this case, the age of a tree from its diameter, the predictions we're going to make are based on this line. That is, we're going to say, look, we have a line going through here. If you tell me a diameter of a tree, if we go to some tree that's not in our sample, we measure its diameter and say that its diameter is about 20, from this graph, it looks like its age will be about 110 years old. So in this section, this is what we're going to be doing. We're going to be trying to make predictions of one value of a variable from another. And so what we'll see in this section is a few things. Well, I drew a line up there, and I did it using software, but this line is called the regression line. It's our line of predicting values of y from values of x. So we'll see how to find this line. Both, not really by hand, I guess. We won't ever fully do it by hand, but mainly using software. We'll see how to make predictions. So how to use the regression line to make predictions. In this case, I want to be able to predict the age of a tree based on its diameter. And one other big thing we'll look at is we'll quantify how good these predictions are. Or another way of saying this is, these trees in the old growth forests, they're all different ages. To what extent, how accurate are our predictions of ages based on the diameters? Do the diameters fully explain the ages of the trees, or is it that there's something else going on? And you can maybe guess from looking back at this plot that because everything doesn't fall on the line, this prediction isn't perfect. So we'd say, look, this is not a perfect prediction. We don't fully get the ages based on the diameters, but we'll see how to quantify that, right? Rather than just saying, yeah, it's kind of close to the line, or the line's not very good, we'll put a number to it. So that's the goal of this section, and there'll be some other details as we go through, but the overall idea is one population, two quantitative variables where there appears to be a linear relationship. How do we find a regression line? How do we use this to make predictions? And how do we quantify how good these predictions are?